Video number 227, multiplying fractions. Let's take a look at these three relatively real-life examples. If you were to take a look at a half gallon, half a gallon is definitely half of 128 ounces, which of course would mean 128 divided by 2, so therefore 64 ounces. A quarter gallon, also known as a quart, would give us 1/4 of 128, which is 128 divided into 4 pieces, okay? So what we're looking at here is the fraction divides the whole number into the number of pieces. So if we had 3 quarts, for example, 3 quarts, we have 3/4 of a gallon, 3/4 of 128 ounces. Then we have 3 times a quarter gallon. That's where we really have 3 quarter gallons, 3 1/4 gallons. So 3 times a quarter gallon. Well, a quarter gallon is 32, so therefore we would take 3 times 32 to get 96. So what we're hopefully trying to understand here is what it really means to multiply fractions. What does it actually mean? And so far, the denominator divides into the numerator, and that's what we've discovered. There's another way to do this last one. We could do 3/4 times 128 over 1, and we will get 3. Now check this out. This fraction setup is virtually the same as this. If you had 3/4 of a gallon, you could have 3/4 of a gallon, right? 3/4 of 1 gallon is 3 gallons divided into fourths. See that? So it doesn't matter where you put the numerator and denominator. You can swap the denominators around and you'll still end up at the same place. You can either do 3 times 128 to get 3 times, now this would be a total of 3 gallons, 3 gallons divided into 4 pieces. That's 96 ounces. Or we could take the quarter gallon and multiply it by 3 and also get 96 ounces. Sometimes you'll see the ounces written as OZ, sometimes it's written out OUNCES. All right, this is what we have discovered. Again, ladies and gentlemen, there are no rules in mathematics, there are only discoveries. We have discovered that if you wanted to multiply 2 fractions, we would multiply the numerators straight across, multiply the denominators across. There you go. So here's 3 examples. 3/8 times 9/5. Yada, yada, yada. Press pause and write them down if you want. Here are the solutions. In the first example, we're going to multiply straight across. 3 times 9 is 27. 8 times 5 is 40. That's it. In the second example, there's 2 ways to do this second problem here. This 4 over 15 times 9/5. There's 2 ways to do this. You could multiply across and get 36 over 75. Then reduce the fraction by dividing both the numerator and denominator by 3 to get 12/25. Another thing we could have done, and the reason we want to know this second method, even though this is probably this method here of multiplying first and then dividing afterwards, probably easier here. In this next example, we're going to want to know this second strategy of expanding the numerators. Notice here, you can expand this to 2 squared, 3 squared. So there's your 4 times 9. Denominator, 5 times 3 times 5. So this is 5 times, this is the 15 times the 5. Then what you can do is you can reduce 1 of the 3's in the numerator with this 3 in the denominator, leaving you with 4 times 3, which is 12. 5 times 5, 25. All right? So that would be this method number 2 is expanding and then reducing first. So you can either multiply, then reduce, multiply, then simplify, or simplify first, then multiply, okay? And that's why for this one, we definitely want to expand the 6 and 75, expand each of these numbers so that we can reduce first. We don't want to do 6 times 75, although 6 times 75 isn't all that bad. That's just 150 times, well, let's see, 150 times 3, which is 450, so that's not too bad. But 125 times 27, we definitely don't want to have to mess with this. So what we'll do is we'll go ahead and expand the 125 is 5 times 5 times 5, right? We do prime factorization. 27 is your 3's, 6 is 2 times 3. 75 is 25 times 3. So there's your 2 5s times the 3. Then we'll go through and reduce first. This 3 might cancel with this one to get a 1, right? 3 divided by 3 is 1. 5 divided by 5 is 1. 5 divided by 5 is 1. And 3 divided by 3 is 1. So we're left with a 2 in the numerator, and then 5 times 3, bam, 15. So there's definitely a good benefit to knowing different ways of doing the same problem. Okay, then you can choose later on, given different circumstances. Now we have a whole number times 4/5. We have a mixed number times 4/5, and then we have 3 fractions, or actually 3 numbers being multiplied together. It's not really a fraction, although you can call it 7/1. Let's see how all 3 of these shake down. 7 times 4/5 gives us 7/1 times 4/5. You see, 7 is the same thing as 7 divided by 1. So you can just rewrite this so that you can go ahead and multiply across. So 28/5 is 5 3/5. In the second example, we're going to change the mixed number to an improper fraction. That's why we worked on those in the previous videos. So we have 3 times 5, that's 16/3, times 4/5, so therefore 64/5, which is 4 4/5. And then the last one, we'll go ahead and change both mixed numbers to improper fractions. Got 7/1 to join the mix. And of course the 32 and 4 cancels down to an 8/1 because 32 divides by 4. So therefore we'll just reduce the 32 down to an 8 as we reduce the 4 down to a 1. We basically divided both the top and bottom by a value of 4. Then of course you just multiply across. 616/5 turns into 123 1/5. So there you have it, ladies and gentlemen, multiplying fractions.